Size of a molecule of a liquid. Let us find the size of a molecule of a oleic acid. First of all, we make 1 by 500 solution of oleic acid is prepared in alcohol by dissolving 1 cc of oleic acid in 500 cc of alcohol. Now sprinkle some lactopodium powder gently on the surface of water contained in a large straw. Put n drops of the solution on the surface of water. Lycopodium powder does not allow the drops of oleic acid to come in contact with water, as oleic acid dissolves in water. Drops of oleic acid spreads into a circular film. In this way, a film of oleic acid is formed. This film is stressed so that its thickness is just equal to the molecular size. With the passage of time, alcohol is evaporated and a thin layer of oleic acid is formed on the surface of water. The area of this thin layer is measured with a tracing paper and a graph paper. Let volume of n drops equals to n into V. Now volume of oleic acid is oleic acid in n drops of solution NV into 1 by 500 cc. Now the thickness of film. Now the thickness of film equals to volume of film by area of film. Hence thickness of film T equals to NV by 500 into 1 by A into cm. Where is the area of film? Since the thickness of film is equal to the molecular size and hence size of the molecules can be calculated. Size of a nucleus of an atom. Rutherford's method of alpha particle scattering. The distance of alpha particle from the nucleus at which the kinetic energy of the alpha particle becomes zero is known as the closest distance of approaches of the alpha particle. The closest distance of approach d of the alpha particle is approximately equal to the size of the nucleus. Now some practical unit of mass. Atomic mass unit AMU. This unit is used to measure the atomic and nuclear masses. Atomic mass unit is defined as 1 by 12th mass of one atom of 6C12. That is 1 AMU equals to 1 by 12 into mass of one atom of 6C12. Equation 1. Now we know that mass of 6.023 into 10 to the power 23 atoms, that is Avogadro's number, of 6C12 is 12 gram. Hence mass of one atom of 6C12 equals to 12 gram by 6.023 into 10 to the power 23. Now from 1 AMU equals to 1 by 12 into 12 gram by 6.023 into 10 to the power 23. Solving we get 1.66 into 10 to the power minus 24 gram, or 1 AMU equals to 1.66 into 10 to the power minus 27 kg. This mass is equivalent to the mass of a proton or a neutron and is order of that. Second, Chandrasekhar limit, CSL, Chandrasekhar limit, equals to 1.4 times the mass of Sun. It is the largest unit of mass. Third, 1 metric ton equals to 1000 kg. Now method of measurement of inertial mass. Inertial mass can be measured by using an inertial balance. It consists of a long metallic strip. One end of the strip is clamped to a table and the second in vibrates horizontally. Let T1 be the time period of vibration of the strips with mass m1 and T2 be the time period with mass m2. Now m1 proportional to T1 square and m2 proportional to T2 square. Hence m1 by m2 equals to 2n square by T2 square. Thus two unknown masses can be compared by knowing the values of T1 and T2. If mass of a standard body is known, the mass of other body can be calculated. The variation of initial mass with its time period of vibration is shown in the figure. Measurement of gravitational mass. Gravitational mass of a body is measured with a common balance or a physical balance. Based on conversion of unit to another unit, 1 parsec equals to 2.08 into 10 to the power 12, 10 to the power 16 meter. 1 light year 9.46 into 10 to the power 15 meter. 1 AU astronomical unit 1.5 into 10 to the power 11 meter. 1 micron 10 to the power minus 6 meter. 1 nanometer 10 to the power minus 9 meter. 1 angstrom 10 to the power minus 10 meter. 1 Fermi 10 to the power minus 15 meter. Question: the average wavelength of the yellow light emitted from a sodium lamp is 5893 angstrom. Expressed in nanometer, wavelength 5893 angstrom. But 1 angstrom equals to 10 to the power minus 10 meter, which is equals to the 1 by 10 into 10 to the power 9 meter, 1 by 10 nanometer. Hence wavelength equals to 5893 into 1 by 10 nanometer equivalent to 589.3 nanometer. Second, the thickness of a hair is measured using a microscope of magnification 100. The average width of the hair is found to be 3.5 millimeter. Find the thickness of the hair. The thickness of hair 3.5 at 100 millimeter, 0.035 millimeter, 3.5 into 10 to the power minus 2 millimeter. The average distance from the earth to the sun is 1.49 into 10 to the power 11 meter. Find out the value of 1 parsec in meter. According to definition of parsec, r by 1 parsec equals to 1 second of arc equals to 1 by 66 into pi by 180 radian, where r is the average distance from the earth to the sun. Hence 1 parsec equals to r into 60 into 16 to 180 by pi meter. Now r is equal to 1.449 into 10 to the power 11 meter. So 1 parsec will be solving 3.08 into 10 to the power 16 meter. The parallax of a heavenly body measured from 2 points diametrically opposite on Earth's equator is 60 seconds. If the radius of Earth is 6.4 into 10 to the power 6 meter, determine the distance of the heavenly body from the center of Earth. Convert this distance in AU, astronomical unit. Given AU equals to 1.5 into 10 to the power 11 meter. Given r equals to 6.4 into 10 to the power 6 meter, d equals to 2r distance. Hence 12.8 into 10 to the power 6 meter d. Now theta equals to 60 second, 1 by 60 degree, pi by 180 into 1 by 60 radian. The distance of heavenly body from Earth is given by r equals to d by theta. Solving, we get 4.399 into 10 to the power 10 meter. Hence r equals to 4.399 into 10 to the power 10 divided by 1.5 into 10 to the power 11 AU equals to 0.293 astronomical unit. Total time taken by a laser beam to return to the earth after reflection from the moon is 2.56 seconds. Calculate the distance of the moon from the earth. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. Time taken by laser beam to go to the moon 2.56 by 2, 1.28 second. Hence c equals to 3 into 8 10 to the power 8 meter per second. Hence s distance between Earth and Moon, S equals to C into T, which comes out to be 3.84 into 10 to the power 5 kilometer. The distance of the Sun from the Earth is 1.496 into 10 to the power 11 meter, that is 1 AU. If the angular diameter of the Sun is 2000 second of arc, find the diameter of the Sun. Here theta 2000 second equals to 2000 by 60 into 60 into pi by 180 radian. Hence d equals to 1.496 into 10 to the power 11 meter. From figure, theta equal to d by d. Solving, we get d equals to 1.45 into 10 to the power 9 meter. The angle of elongation epsilon of the planet Mercury is 24 degree. Find A, the distance of the Mercury from the Sun, and 2, the distance of the Mercury from the Earth. Here epsilon equals to 24 degree and RMC with the distance of the Mercury from the Sun and RME with the distance of the Mercury from the Earth. Using RMS equals to sin EAU, we get RMS equals to 0.4067 into 1.5 into 10 to the power 11 meter. That is RMS equals to 6.1 into 10 to the power 10 meter. Similarly, we get RME equals to 1.37 into 10 to the power 11 meter. Suppose the orbit of the Mercury around the Sun is circular and it's the same question. Sorry. Two cesium clocks, if allowed to run for 10 years, may differ by only about 0.02 seconds. Calculate the degree of accuracy in the measurement of time interval of 1 second. 10 years equals to 3.15 into 10 to the power 8 seconds. In 3.15 into 10 to the power 8 seconds, the difference in time interval of two clocks is 0.02 seconds. Hence, in 1 second, the difference will be 0.02 by 3.15 into 10 to the power 8 equal to 0.0064 into 10 to the power minus 8. Hence, degree of accuracy in measuring a time interval of 1 second is 1 part in 1 by 0.0064 into 10 to the power minus 8 equals to 10 to the power 11. Nuclear radius is given by r equals to r naught into a to the power 1 by 3, where a is the mass number, where r is the radius of the nucleus, a its mass number, and r naught is a constant equal to about 1.2 Fermi, so that nuclear mass density is nearly constant for different nuclei. Given 1 am equals to 1.66 into 10 to the power minus 27 kg and 1 f equal to 10 to the power minus 15 meter. Given radius of nucleus r equals to r naught a to the power 1 by 3. Hence, volume of the nucleus V equals to 4 by 3 pi r cube, or equals to 4 by 3 pi r naught q into a. The mass of nucleus, whose mass number is a, equals to a amu. Or a into 1.66 into 10 to the power minus 27 kg. Hence, density of nucleus. Rho equals to mass by volume equals to, putting the value, we get density equals to 2.3 into 10 to the power 70 kg per meter cube. This shows that nuclear mass density is independent of the mass number A. The size of the hydrogen atom is about 0.4 angstrom. Calculate the total volume in meter cube of a mole of hydrogen atom. Given 1 angstrom into 10 to the power 10 meter. Here R equals to 0.4 angstrom, 0.4 into 10 to the power minus 10 meter, or 4 into 10 to the power 11 meter. Volume of one atom of hydrogen 4 by 3 pi r cube. Putting value, we get 2.68 into 10 to the power 31 meter In 1 mole of a hydrogen, number of atoms equals to Avogadro's number 6.02 into 10 to the power 23. Hence volume of atoms in 1 mole guna volume of 1 hydrogen atom equals to 1.6 into 10 to the power minus 7 meter cube. The nearest star Alpha Centauri to our solar system is 4.29 light years away. Calculate this distance in terms of parsec. How much parallax would this star show when viewed from the position of the Earth? 6 months apart in its orbit around the Sun. Given a radius of Earth orbit around the Sun is 1.5 into 10 to the power 11 meter. 1 parsec equals 3.084 into 10 to the power 12 meter, and 1 light year equals to 9.46 into 10 to the power 15 meter. Distance of Alpha Centauri from the Earth 14.58 into 10 to the power 15 meter. Hence R equals to 1.316 parsec. Let phi be the parallax shown by the star when viewed from the position of the Earth 6 months after. Then phi equals to d by r equals to 1.52 second. A laser light beam sent to the moon takes 2.56 seconds to return after reflection at the moon's surface. Calculate the radius of the lunar orbit around the Earth. Time taken by the laser beam to go from Earth to the moon is t equals to 2.56 by 2, 1.28 seconds. Hence c equals to 3 into 10 to the 8 meter per second. Hence distance between moon and Earth s equals to ct 3.84 into 10 to the power 5 kilometer. The light emitted by a quasar takes billions of years to reach the Earth. What is the distance of a quasar from which light takes 2 billion years to reach the Earth? T equals to 2 billion years. 2.0 into 10 to the power 9 years. 2.0 into 10 to the power 9 into 365 into 24 into 60 into 60 seconds. Now speed of light equal to 3 into 8 10 to the power 8 meter per second. Hence distance s equal to c into t. Putting value we get 18.9 into 10 to the power 22 kilometer. The photograph of a house occupies an area of 1.75 cm square on a 35 mm of slide. The slide is projected onto a screen and the area of the house on the screen is 1.55 meter square. What is the linear magnification of the projector screen arrangement? We know magnification size of image by size of object. Hence aerial magnification area of image by area of object. Here area of image 1.55 meter square and area of object 1.75 cm square, 1.75 into 10 to the power 4 meter square. Hence area of magnification 8857.14. Hence linear magnification under root aerial magnification equals to 94.1. Now dimensions and dimensional analysis.